Hey guys, so for this video we are going to start with example 2. Rewrite each in vertex form, so that's your H and K form. Graph each parabola by hand, that means no calculator at all. So in fact, I don't want you to use a calculator at all on this whole thing, okay? Determine the intercepts and local min or local max if applicable. So I'm gonna write all of this right here, rewrite in vertex form. So vertex form. And what I'm going to do first is, how about this? Let's separate these three, okay? So I don't, I'm gonna give each one its own personal space. So let's box my vertex form here. If I don't do this ahead of time, I tend to forget which piece I'm going to, or which piece I'm supposed to answer and which one I have not answered yet. It says here, determine the intercept. So let's write x-intercept here. Okay. Y-intercept. Intercept means both x and y. Okay. Then a local min or local max. And also, I think that's it, right? Each in vertex form. Graph by hand, which we have not done, which I'm going to need to do. Determine the intercepts, x and y. Local min or local max. So here we go. Local min slash local max. We're going to have to decide which one it is. So let's box those in. So my equation is y equals x squared minus 12 plus, I'm sorry, there's a typo. Can you add in an x right there? Minus 12x plus 46. Let me go to my unit notes and add that x on there. I type these all by hand, so sometimes I do have typos more often than I like. Okay, so here we go. So y equals x squared minus 12x plus 46. So it's a typo, so add an extra x right there for me. To complete this square and put it in vertex form, we are going to, here we go, y equals x squared minus 12x. Put the x's together, okay? I would like for you to put the x's together. This constant number, what I would like for you to do is move it slightly over here. So I'm gonna find C, another constant, so I can complete this square, or I can factor this out perfectly. Move 46 slightly over here. See that little spot? Okay. Let me find a red pen. And in finding a value to fill in this blank space, it's the same as how the same two steps that we did in the circles. So step number 1, or first step, we are going to take half of negative 12. Well, half of negative 12 is negative 6. Then step number 2, second step, we are going to square it. Okay. Well, when I square a negative number, it's going to be positive. So negative 6 times negative 6 is going to be a positive 36. And I need to add it right here, add 36. Well, I can't go in and just add a 36, right? Then that would change my original equation. So if I added a 36, I would then need to immediately subtract a 36, okay? And I'm still on this line. And the reason is this. If I added 36, now I've just added, okay? This is y equals x squared minus 12x. So those three things right there are still the same. But then this would be an addition, a plus 82. But my original equation said it's a plus 46. So notice how I went and changed the equation, and I can't do that. So if you added something, you have to go and immediately subtract that something. Okay? So that way, you are really technically adding a 0. Okay? So you're not changing anything. So when you factor it out, you would only factor these three terms. See that right there? So now that I'm going to factor out, I have y equals, okay, this is an x minus 6 twice. Or I can write it as a square term. A positive 46 and a negative 36 is going to give me a positive 10. Okay? And if I wanted to, I can FOIL this back out and it should be the original equation. So now that that's my vertex form, I'm going to write it up here, f of x or y equals, doesn't matter how or what you use, x minus 6 squared plus 10. And that's my answer. Now let's look for the x-intercept. Okay, x-intercept is when y is 0. So 0 equals x minus 6 squared plus 10. Then you would have to solve for x by first subtracting 10 to both sides. So 0 minus 10 is negative 10 equals x minus 6 squared. I'm going to root both sides. Take the square root. Okay. Well, when I take the square root, okay, this side, it's okay. But can I take a square root of a negative number? You can't take a square root of a negative number. Therefore, no x-intercept. Okay? Because it's not possible. You can't take a square root and solve for x from a negative 10. So x-intercept, we're going to say none. This means it's not going to cross over my x-axis. Okay? Y-intercept, y-int, is when x is 0. So here's my equation. Okay? Again, we're using the same equation. Y equals x minus 6 squared plus 10. Y-int is when x is 0. So here we go. Y equals 0 minus 6 squared plus 10. Well, 0 minus 6, let's move up a little bit, is negative 6. And I need to square that, so that's really 36. 36 plus 10, that's really 46. So y-intercept, it's x is 0, and y is 46. Not bad, right? Now let's determine whether we have a local min and local max. Okay, and there's no work needed to be done at all. Local min and local max depends on how it opens. Would you agree that this is a positive one? Positive one meaning that it opens up. Okay? Positive one means it opens up. If it opens up, okay, then you would have a local min, because then it would look like a V that's upside, a U that's upside down. So right now, why don't you circle local min for me? Go ahead and circle local min. Okay? Circle the local min. Because you have to pick. You can only have one or another, but not both. So circle local min. Then the answer to your local min is simply the vertex. Okay? And the vertex is going to be, this is x minus 6, so the x coordinate of this vertex is positive 6. And this is a positive 10 already, so we do take its positive, which is 10. And that is all the stuff I need to answer. So now let's go and graph it out. Here we go. Okay. I'm going to get a straight edge. Looks like I have a lot of positive y values, so it looks like I don't need a lot of negative y in the bottom. So when I draw out my coordinate, my x-axis and my y-axis, okay, I don't need a lot of negative y, right? So my highest is at 46, so let's do this by 20. 20, 40, 60, okay? X looks like I kind of need to go at about 6, so let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Because X is by 1 unit, I don't need to label it. So let's plot my vertex, which in this case, it can also be known as the local min. Did you circle that already? So go 6 and 10. 1, 2, 3, 4, 5, 6, 6 and 10. Okay. Then I have a y-intercept at 0, 46. So here's 40. 46 is somewhere here. Okay. So connect these two. Remember, it is supposed to look like a U. So round it out. Do not make it look like a V. So this is 0, 46. Label this point. Because this is a parabola, so it's supposed to be symmetrical about this line called the directrix. Okay. This is called the directrix. I'm sorry, this is not the axis of symmetry. Axis of symmetry. Okay. It's supposed to be symmetrical about the axis of symmetry. So all I have to do is go 6 units on the right, because to get this point, I went 6 units from my vertex. So now I can go 6 units to the right. 1, 2, 3, 4, 5, 6. And go up at 46 again. Okay. So this is actually, this point is going to be labeled 12, 46 because it needs to be symmetrical. See? So the left and the right, they need to be equal distance from the vertex. All right. So I believe we answered all the questions, right? X, Y intercept. Let's move on to the next example, B. Example B is asking for the same thing because it's still under the same set of directions. So the first thing is we want to do the vertex form. Let's box this up. We want to find x int. Let's box that up. Y int. Box that up. And then we want to find, hey, is it the local min or local max? And remember, you can only have one, so make sure you circle the correct one. So let's write the question over again. X squared minus 12x plus y plus 40 equals 0. The first thing that we need to do is to get y by itself. So what we are going to do is, let's see, it's easier just to move this negative y over. Okay, so let's do it. Minus y, so here we go. We are going to end up with an x squared minus 12x plus 40 equals to negative y. Well, I can't really have a negative y, so make sure we're going to multiply both sides by a negative 1 to get rid of it. So multiply this side by negative 1, multiply this side also by negative 1. What you do to one side, you have to do to the other. So we are now going to have a positive y, which I'm going to write over here, equals to a negative x squared positive 12x, because you have to distribute this, minus 40. Okay. So that's just me solving for y, getting y by itself. Now, if you are here and you want to move this over here, and this over here, you can also do that as well. Okay. Either way, you would still have y equals negative x squared plus 12x minus 40. So this is now back to similar to this, right? With a minor change, there is a negative right here. So step number 1, I would like for you still move this constant a little bit out. Okay, so minus x squared plus 12x, give yourselves a space, move the minus 40 slightly over here because we're going to have to find this number. Just like the circle, you may not have a leading coefficient here. Okay, so I'm going to have to factor it out just from these things right here. Okay, again, just from these two things right here. So y equals, I'm going to take out that negative x squared. Now that becomes a negative 12x. This is still plus. That will always be a plus. Okay, and we are not taking this negative from here. So keep this just like that. Okay. All right, so let's find this number. Half of negative 12 is going to be negative 6. Square it. That's going to give me a positive. Notice that this is always positive because you have to square it. So it's a positive 36. Okay. And earlier over here, we talked about if we added something here, we need to then immediately go and subtract it right away because our goal is to really add nothing. Okay. But this 36 is being multiplied to this negative 1. So I need to also multiply this to a negative 1. Okay. So because we did that, now we have this awesome y equals negative in the front still, that doesn't go away, minus 12x plus 36 equals, I'm sorry, bring down the minus 40. A negative 36 and a positive 36 is going to be a negative 36, I'm sorry. A negative 36 and a negative 1 is a positive 36. Okay. So we're going to combine those. So y equals, negative is in the front. Let's factor this out. It's something square. So x minus 6 twice, or better if we write this x minus 6 squared. Combine these, negative 40 and a positive 36 is I'll wait for you, a negative 4. Okay? And this is my vertex form. Okay? So that goes on the top. So y equals negative must be in the front, x minus 6 square minus 4. Now let's go and find the local min or local max right away. So to find the local min, local max, we need to decide, hey, how does it open? Okay, does it open up or is it down? So let's look at these two. Look how similar they are, right? This one has a negative, this one has a positive. Because it's a negative, we know that it opens down, okay? If it opens down, am I going to have a local min or local max? I would want you to circle the local max. So circle this right now, okay? So, and it's a local max, then we just have to find the vertex. And the vertex is, because this is x minus 6, it's going to stay as a positive 6. And outside you don't switch, so that's staying at a negative 4. Now let's go find the x and y intercept. X int, meaning y must be 0. So here we go, negative x minus 6 squared minus 4. We are going to add 4 to both sides. So 4 equals negative x minus 6 squared. We are going to divide both sides by negative 1. So negative 4 equals x minus 6 equals x minus 6 squared, I meant. Okay. Now we are going to root it. Okay. All right. So you tell me, are we going to have an x-intercept? If you say no x-intercept, why did you say that? Okay, no x-intercept because you cannot take a square root of a negative 4. No x int. So on x int, we're going to write none. All right, so now let's do y int. Y int is when x is 0. So I'm going to use this equation right here. See this right here? Okay. So y equals negative 0 minus 6 squared minus 4. Okay. Negative 6 squared is going to be positive 36 times a negative in the front. So that's now a negative 36. Even though when a negative and I square it, it's always positive. The only reason that I would have a negative here because there's a negative 1 in the front. Minus 4, this is going to be a negative 40. So it looks like y-intercept when x is 0, and I'm going to end up at a negative 40. Now, looks like my y values are mostly negatives, so let's draw a coordinate plane of mostly negative values on the y. Okay. Okay, vertex, I have 6 comma negative 4, so here we go. And y-intercept is at negative 40, so how about we do it by 10? 10, 20, 30, 40, so negative 40. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 1, 2, 3, 4, 5, 6. So negative, positive 6 and negative 4, so this is my vertex. Okay, and the y-intercept is 0, 40, so here's 0, 40. So connect that. And remember a parabola, moving up really quickly, a parabola is symmetrical about its axis of symmetry. So if I counted 6 units to the left and went down 40 units, I would have to do the same. Count 6 units to the right, 1, 2, 3, 4, 5, 6, and go down 40 as well. So here's my other dots. So label this 12 comma negative 40. Okay, there you go. And let's see if it matches our answer. We have one y-intercept, okay, which we have. We have no x-intercepts at all, which that explains why we are not touching or crossing over your x-axis. So that makes a lot of sense. So we are now on our last example of number 2, or last problem of example 2. And we're going to do the same exact thing, okay? We are going to write the vertex form up here. Vertex form. We'll box it up, so we'll come back and fill our answer. x-intercept, hopefully we can find some this time. Y-intercept, okay, and local min and local max. Okay, hopefully you guys circle the correct one. You cannot leave it blank. Okay, so the first two problems, make sure you go and circle the correct one. All right, so let's write the question back. Okay, 6x squared plus 12x plus y plus 13 equals 0. And again, I'm going to have to get y by itself, so we are going to move the y over here. So positive 6x squared plus 12y. Move this over, so now I have a positive 13 equals a negative y. Okay. Because I have to get y by itself, not negative y by itself. So now I have to go and get rid of my negative 1. So I'm going to multiply each side by negative 1. What you do to one side, you have to be completely equal, hence equation. Okay. So now we are ending up with, I'm going to write y equals negative 6x squared minus 12x and a minus 13. Okay. So now that we have an equation with y equal to it, we are going to do completing the square just like these first two. So here we go. Y equals negative 6x squared plus 12x. Give myself a space here. And then move this 13 over slightly to the right. Is that a leading coefficient of 1? If you said no, make sure we factor it out. Okay, so y equals negative 6, and only factor it out from these two terms. So that means I'm still bringing, okay, I'm still bringing this minus 13 down, straight down. I'm not doing anything to it. I'm not taking the negative 6 out of the negative 13. So if I did that, I have positive x squared. Be careful. If you are dividing positive 12x to a negative 6, I'm going to end up with a negative 2x and give myself a blank line so we can fill it in. Okay. So now, look at that. That's a leading coefficient of a 1, right? So we're going to take half of negative 2, which is negative 1. And I'm going to square negative 1, which will always be a positive, happens to be 1. Well, I just went and added a positive 1. So I have to go and subtract a 1 from this constant right away. But this positive 1, this 1 right here is being multiplied to a negative 6. So whatever I added, I need to subtract it. And whatever it's been multiplied to, I also have to multiply to the same thing. Okay? Your goal is to really add a 0, not anything else. So now that we have those pieces, let's make this over here. Now I have y equals negative 6 is still in the front. I can factor this out. This is something square. Okay, so that goes in here as minus 1. And a negative 13, let's bring that down. A negative 1 and a negative 6 is going to be a positive 6. And then we will need to combine those. So let's see what we're going to end up with. Y equals negative 6 times x minus 1 squared. A negative 13 and a positive 6 is going to give me a negative 7. So this is my vertex form. So here we go. Y equals negative 6 times x minus 1 squared minus 7. Okay. And if I ask you to graph this using transformations, this is a reflection over the x-axis. This is a vertical stretch by factor of 3. This is moving to the right by 1. And this is moving down by 7. So this is kind of connecting with the last unit. Okay? Except that you're finding this all by yourself, this format. So from here, let's look for x-intercept. X-intercept is when y is going to be 0. So 0 equals negative 6 times x minus 1 squared minus 7. I'm going to add 7 to both sides. So this is now 7 equals negative 6 times x minus 1 squared. I am going to divide both sides by negative 6. So this is a negative 7 over 6 equals x minus 1 squared. I'm going to root it, take a square root. Okay. Well, we kind of for some reason, the problems I picked out for your notes, none of it have any x-intercept, right? No x-int. Just by chance, okay? So don't think that we don't have intercepts always. Just by chance that we don't have any. So that was kind of strange. Okay, so that's really none. Y-intercept is when x is 0. So that means y equals, again, I'm using this piece right here. Okay. When x is 0, okay, I have -6. 0 minus 1 is -1, and I square that, minus 7. -1 squared is +1. +1 times -6 is going to be -6 minus 7, and that's going to end up as a -13. So y int 0, comma, -13. Okay. So now let's talk about our, how does it open? Does it open up or does it open down? Because we have a negative, so this one opens down, which makes sense because if you were to reflect it over the x-axis, it is now opening down. It opens down, so now we would have a local min or local max. You would have a local max, so make sure you circle local max. And let's find the vertex. And the vertex would just be +1, comma, -7. So this is an x minus 1, which you have to take its opposite. Remember, this is going to the right, so that's why it's now +1. This is still going down by 7, so that's why it's still going to keep its negative sign. Okay. We now have enough information to graph, so let's move it up a little bit. And looks like, again, I have more negative y values, so I'm not going to need a lot of positive y's. I'm not going to need too much on the top. Okay, that's my x-axis. Here's my y-axis. Notice how I focus on a lot of it on the negative. I think since I have -13, I can totally do 13 take marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. I have, looks like, very small x values here, so I can keep my tick marks on the x large, right? So let's plot the dots. 0, -13. This is this dot. Okay. 0, -13. My local maximum, hopefully you circle that, is 1, comma 7. So 1, 2, 3, 4, 5, 6, 7. There's my vertex. Because it's symmetrical, I can definitely go to this side, right, to plot my symmetrical point, which is really 2, comma, -13. And connect them. Please don't make a V. Okay. There. Oh, you can't really see that. My bad. Okay. Sorry. I was just trying to find this dot. Okay. So notice how it's not intersecting the x-axis, which matches up with our no x-intercept. And for some reason, all 3 of these keeps saying that we don't have an x-intercept, but then that is not always the case, okay? Just by random, by luck. I just made these up, okay? So make sure you don't assume that it will always have no x-intercepts. This is the end of our notes. I will see you next time. Bye-bye.